So looking at the information on the board, what we're going to see is that cosine pi over 2 minus cosine theta is equal to sine theta. So now here's the key. The idea is this: that you cannot take this apart. You can't apply this through to this equation and solve it in this manner. Because what that will do is that'll actually get you the wrong answer, okay? So you can't do that. So what you're going to have to do is when you see something like this, you're going to have to use the different equations that you'll get here, the sum and differences of identities. And what those would be is cosine, so whatever, they use like a little funny A and a B, so it's plus or minus, so it's going to go both ways, but when it's cosine, what you're going to see is going to be like this. You'll actually get cosine A, cosine B, minus or plus sine A, sine B. So what you're going to do is you're going to set it up like so. Okay, so using that identity. So if I have this, okay, I plug in this identity. So what's going to happen is going to be cosine pi over 2, cosine theta, minus, so this is because it's minus, sine pi over 2, sine theta. And we're trying to prove this. Remember, we're keeping this the same. Now, when I put that in, what happens? Well, what is cosine pi over 2 on your unit circle? Well, we know that to be 0. We know this one to be 1. So what happens to this, ultimately to this whole thing? Okay, it disappears, okay? So when it's the, I'm sorry, these are opposites, it's 1 plus. So when it's minus, it's plus. So here it's plus. So that's why it's going to be, so it's going to be 1 and sine theta. Notice this all goes away because 0 times cosine is 0, and 1 times sine is going to be sine theta. So notice that they match. So it's not a very difficult thing, but it's a quick plug-in using these identities. So another identity that you would use is sine, and it's sine plus minus b equals. And so this is how you would plug in for sine. You plug in sine this way. Sine A, cosine B. Sine B, cosine A. Okay? All right? And then our tangent one, so these are the 3 things you have to write down. Our tangent one is going to be tangent AB. What's that one going to be? Tangent A plus or minus tangent B all over 1 plus minus tangent A, tangent B. Okay, so what you're doing here is you're plugging in, okay? So plugging in accordingly, so minus and plus. So if it's tangent minus B, if it's tangent minus, it's going to be tangent A minus tangent B, 1 plus tangent A, tangent B. And so it's very important you follow those, your subtraction, your multiplication, and in identity, in subbing in. So, good example. So let's solve sine 7 pi over 15. Or 12, sorry. Sine 7. So first off, what do? So we have to get this into fractions that will work for us. We have to get it into fractions that work for us to be able to solve this. So what do? Step 1. What can this be broken down to? 3 pi over 12 plus 4 pi over 12. Right? Would that be equal? Yeah. So sine 3 pi over 12 plus 4 pi over 12. So, question for you. If that's the case, what does that become? Pi over, we'll put them in order. Pi over 3, pi over 4. Okay? All right? So we don't confuse anybody. So now plug in to the appropriate sign, okay? So here we go. So it's going to be sine A, 3, cosine pi over 4, plus, because we're doing plus, right? Plus sine pi over 4, cosine pi over 3. So now, can we solve this? Sure can. Take your little chart, sine pi over 3. Sine pi over 3 is the square root of 3 over 2 times cosine pi over 4, 2, plus square root of 2 over 2, pi over 3 is 1/2. So, finish up our information. Square root of 6 over 2 plus square root of 2 over 4. I'm sorry, it's over 4. Okay? And is that your final answer? Sure is. So this would be your answer when you plug it in. Okay? So they're going to give you an equation that looks like this. You break it apart into two fractions that will come out to even fractions on your chart. Okay? If they give you a degree, then you use degrees that would add up, that would be able to be used on your chart. So let's give you an example. Tangent 15. How would you solve this? Tangent 15. What are the, well, I'm going to need this here. So we're going to use, obviously we're using tangent, right? Okay, so we got to figure out now, how would we break it apart? 45 minus 30, right? Because that's going to give me 15, right? That's going to give me to equal 15. So now I can go to my chart and solve. So what is that going to give me? 45 and it's minus, so we're going to do the minus one. So it's going to be tangent A, which is 45, and we're minus, so minus tangent 30 over 1 plus tangent 45, tangent 30. Okay, so now, once you have that, now we have to go, what's tangent 45? Tangent 45 on here is pi over 4, right? Okay, which is it's 1, right? So tangent 45 is 1, right? Tangent 30 is square root of 3 over 3. So 1 plus 1 times square root of 3 over 3. Now what? We're almost done. What can we do? We got to get this to be a fraction, right? 3 plus square root of 3 over, and all over 3. And the fraction is 1 minus, so the top is going to be 3 minus the square root of 3 over 3. 3 plus the square root of 3. 3 plus the square root of 3. So that cancels out here, right? This cancels out here, and we're left with 3 minus the square root of 3 over 3 plus the square root of 3. Right? Okay? So now, what do we have to do? So it gets us to that point, which is good, but we need to get this bottom part up, right? So, if I multiply this like this, what's it going to give me on the bottom? 3, so 9. The middles are going to drop out, and you're left with minus 3, right? All over 9 minus 6 square root of 3 minus plus 3. So finalize 9 So 9 plus 3 is 12, minus 6 square root of 3, all over 6, which reduces to 2, minus square root of 3 over 1. So that's your final answer when you're done. Okay? Using that information to be able to solve that problem. So, basically what they're going to be doing is taking this and evaluating these according to your different sums and differences. Sums and differences, also keep in mind that that is also one that can work and be used if it is necessary to be used. All right, to evaluate and to identify. Okay, all right. Any questions on those? So if they say to you, find the exact value of this expression, cosine A is negative 5/13, and B is in the quadrant 2 with sine B is 3/5. So basically what you're going to have to do is you're going to have to solve for your, using this equation up here, okay? So what they're going to do, they're just making these a little bit more tricky. So they're going to say cosine negative 5/13. That's cosine A equals. And you're going to have to find cosine B. Just wait for a second. And then this one's going to be sine B is 3/5. Okay? And you'll have to find cosine B. Okay? All right? So find sine A and sine B. Okay, so what we're going to do is we're going to find those. Because remember, in order to use one of these, we have to have an A and a B. Okay, so if cosine A is this, cosine B is this. So, right, so let's think about this for a second. What would sine A be? Okay, sine A. Okay, so if we were to solve this, we're going to put this, we would make this sine. So it's going to be using this equation here, okay? Using this equation here. This is negative 5 squared plus sine squared A equals 1. So this is going to be what, 25? So negative 25, 162, 9. So, well, when you do the square, it's positive, so we're going to subtract 25, 169, minus 25 over 169. Sine squared A equals 144 over 169, which, by the way, when we do this, it reduces to sine A equals 12 over 13. Okay? And it's a negative. Okay? Because this is negative, right? All right, so here's that. Okay? Good so far. Because, why is it negative? Because it's in the third quadrant, which is everything's negative in that quadrant. 12, 13. So what's B going to be? How do we solve B? Use the same function, plug it in. It's going to be cosine squared B plus, well, we don't need to put it in. It's going to be 3/5 squared. It's 1. So, what's that going to give me? That's 9 over 25. Subtract 9 over 25. c squared, cosine squared b equals 16 over 25, right? Which is c cosine b equals 4/5. Now, where did it say it was? It was in the second quadrant, right? So therefore, this is going to be negative 4/5. Okay? So that's what that little second quadrant, because if it's in the second quadrant, then it's going to be that number. So now that you have those informations, these two, now that you have these two, now you could solve cosine A plus B or cosine A minus B. But if you don't have these equations with those numbers, you cannot solve the problem, okay? And so it is important that you solve these, because these are equal. So when what happens is you are actually plugging in this decimal in for the whole sine or the whole cosine. You're not actually doing sine or cosine, you're just plugging it in and adding fractions. So let's do cosine AB. So let's do cosine A and B. So what would that be? So here we go, ready? Cosine AB would be, so replace cosine A. What was cosine A? Negative 5/13 times cosine B, which is negative 4/5 plus, it's plus, so we're going to do minus, minus sine A, which is negative 12 over 13, and sine B, which is 3/5. So now we common denominator, 65, right? Okay. So we have 65. So this is going to be 20. So that's going to be a positive 20, and this is minus and a minus, right? So that becomes a positive 36 over 65 equals 56 over 65. Okay? If you were to subtract, you would change, all you would do is be changing this sign. Okay? So any questions on plugging in, that's what you're going to do, and you're using it, evaluating it using the sum and difference. All right? So let's do one more example, and then I'll let you go, and you can kind of, I'm sure you're going to have some questions, but this will get you a majority of the information that you need, okay? All right. So if sine x minus pi over 2 equals negative cosine x, okay? How would I show and demonstrate this? Okay, we've already kind of done this, but let's go through this process. So what would it be? So sine, right? So it's going to be sine x cosine pi over 2 minus cosine x sine pi over 2. Okay, so now what? Cosine, this is 0, right? Minus cosine x, and this is 1. Well, cancels out. What are you left with? Minus cosine x. Look familiar? So basically, you're just plugging and chugging into this information. That's how you verify and make sure you can reduce. All right? Okay. So I think we should leave it at that point. I think if you have any questions, we'll answer them in class. Plug and chug, but make sure you know those 3 identities.